Hello, online MAT 117 College Algebra students. This is a review for some topics in Objective 10 I noticed that many people have not yet learned. The first topic is transforming the graph of a function by shrinking or stretching. In this topic, you will usually be given a problem with two graphs. One will deal with the vertical stretch or shrink, and the other will deal with a horizontal stretch or shrink. The key concepts to remember with this topic are: if you are asked to transform a function of the type y equals a times f of x, then you multiply the y-coordinates of the original graph by a to make the new graph. If you are asked to transform a function of the type y equals f of a times x inside the parentheses, then you divide the x-coordinates of the original graph by a to make your new graph. Let's go into ALEKS and work on an example problem. You are asked to transform each graph as specified below. Your first graph, the graph of y equals f of x, is shown. Graph y equals f of 1/2 x. And for your second graph, the graph of y equals g of x is shown, and you're asked to graph y equals 2 times g of x. We'll start with the first graph. This is in the form of y equals f of a times x, the f of 1/2 x, where a equals 1/2. So we divide the x-coordinates in f of x by 1/2. The best points to transform are the two endpoints, which we can see are -2, -2, and 2, -4. Those are the two endpoints. So we'll transform those two endpoints by dividing the x-coordinates by 1/2. So our first x-coordinate is -2. And we'll divide that by 1/2. So -2 divided by 1/2, which we'll multiply by the reciprocal. So we'll write that as 2 times 2 over 1 is equal to -4. So our first x-coordinate that we transform becomes -4. Our second x-coordinate is 2. And so we take 2 and divide that by 1/2. We multiply that by 2 over 1 again. And this results in 4. So these are our two new x-coordinates. X equals -4 and x equals 4. So we'll go back to our graph in ALEKS and we will plot these new points. So we had x equals -2. We divide that by 1/2, we got -4. The y-coordinate stays the same, but the x-coordinate changes. So now our new point is -4, -2. Then we had x equals 2 here. We divide that by 1/2, and the result was x equals 4. So now our new point is x equals 4, and then -4, because the y-coordinate stays the same. Then we will click our graph button and attach these new points. And this will become our new graph. Now we will transform y equals g of x to y equals 2g of x. And this one is the form y equals a times f of x. So we multiply the y-coordinates of g of x to transform it. With this one, we will look at the two endpoints and the vertex. The y-coordinate of our first endpoint is y equals 4. Well, the actual point is -2, 4. And then our vertex is at 0, 0 at the origin. And then our right endpoint is at 4, 2. So the y-coordinate is 2 for this one. The y-coordinate is 4 for that one. The y-coordinate for the origin is, of course, 0. Our first y-coordinate was at y equals 4. So we multiply 4 by our a value, which is 2, and this results in y equals 8. Our second y value is at y equals 2. So again, we multiply 2 by 2, and this results in 4. And these are the two y values of our new endpoints. And then the vertex, could use that as well. The vertex is at y equals 0, 0 times 2 equals 0. So the vertex will stay at the same spot. Let's now go ahead and plot these points in Alex at y equals 8 and y equals 4. So we're going to plot our first new point, our first new endpoint was at -2, 4, and then we multiplied the 4 by 2, we got 8. The x-coordinate stays the same in this case, and then we plot it at -2, 8. Then the vertex stayed the same, it's still at the origin. And then with our right endpoint at 4, 2, we multiplied the 2 by 2, and the result was 4. So the new point is now at 4, 4. And now we will attach these together by using the graph button. You have to place your first endpoint there, and then your second endpoint, the vertex. Now I'm going to place my first endpoint, the vertex, and then attach it there. Then I went ahead and checked the answer, and we see that the answer is correct. Again, remember the rule. If the coefficient a is inside the parentheses with x, then we divide the x-coordinates by a. If a is outside, being multiplied by the whole function, then we multiply the y-coordinates by a for the transformation. Our next topic will be graphing a parabola of the form y equals ax squared plus bx plus c, integer coefficients. With this topic, you will be given a quadratic function with a leading coefficient that is greater than 1. You will usually be asked to plot the vertex and 4 additional points, 2 on each side of the vertex. To find the vertex, you will need to remember the formula that gives you the x value of the vertex. X equals -b over 2a, where b is the x coefficient in the quadratic equation, and a is the x squared coefficient in the quadratic equation. After this, you will only need to know how to substitute x values into the function, solve for y values, and then plot the points. Let's look at an example problem in Alex. Graph the parabola y equals 2x squared minus 20x plus 46. And again it says, plot the vertex, and then 4 additional points, 2 on each side of the vertex. And then click on the graph icon, and then check the answer. So let's work this out. With y equals 2x squared minus 20x plus 46, we'll start out by finding the vertex. To get the x value of the vertex, we use this formula. So x equals, we have -b. The b value is -20 here. So negative 20. Got to be careful here. The b value is -20, and then you also have a negative outside. So you do write the negative twice, which we will see later will cancel to be positive. And then that's divided by 2 times the a value, which is 2. This now simplifies to positive 20 divided by 4, and 20 divided by 4 is 5. So know that the vertex is at the x value of 5. Now if we substitute 5 in for x in this equation, we would solve for y. I'm not going to show the math here, but if we substitute 5 in for x, we would solve y is equal to -4. So we now know the vertex is at 5, -4, which we could now plot on our graph. 5, -4. That's our vertex. So the graph will start here and open up in that direction from here, which we'll now solve for these points. We have to find 2 points to the left of this vertex and 2 points to the right. The best practice for this is usually to choose the 2 points closest to the vertex. In other words, x equals 4 and x equals 3, and then choose x equals 6 and x equals 7. We will now put this into a table. I have the x values here that we're going to choose, 3, 4, 5, 6, and 7, knowing that 5 is the vertex, which is at a y value of -4. We now need to solve for the y values for the rest of these points. So to start with the first one, we'll substitute 3 into the equation, and the y value we solve for is 4. Then we'll solve for y when x equals 4. The y value we solve for is -2. Then these 2 points that are on the right, because this graph is symmetrical, if we know the 2 points on the left, the 2 points to the right of the vertex should be at the same y values because of the symmetry. In other words, at x equals 3, y equals 4. Therefore, at x equals 7, y is also going to equal 4. And at x equals 6, y will equal negative 2, just as it does at x equals 4. And you can also, plug in 6 into the equation and solve for y, and you should result in negative 2. And if you were to substitute 7 in for x, you should get 4. Let's now plot these points into Alex. So we'll plot 3, 4. Right there. We'll plot 4, negative 2. Right there. And then 6, negative 2. And then 7, 4. 6, negative 2, 7, 4. Now, if we click the graph button, it should fill in for us. Like so. And then we check our answer, and it comes out as correct. This is the final parabola. Again, remember with this topic that you want to start by finding the vertex, as we did here. And then from there, you can map out the graph by choosing some good x values to substitute into the equation. And the good x values we choose are usually the 2 closest values to the left and the 2 closest values to the right of the vertex. Makes it simpler for counting. You could choose different ones, but those are probably the best ones, at least the easiest ones to see.